So, hello, good morning. Today we are going to learn the first chapter from physics. This is force. So, as from the smaller classes, we are learning about force. What is a force? A force is nothing but a push or pull of an object. So, a push or pull of an object is known as force. If consider this is an object, so if we are applying force, then only this object will move in this particular direction. So to make this object to be in motion, or to make this object to move, we have to apply some force. That is known as a push or pull of an object, is known as force. So second, the SI unit of force. So SI unit of force is Newton. So why I am writing this as a capital N, not as a small n? Because so this Newton is given to honor the scientist whose name is Isaac Newton. This also we have learned very briefly in our previous classes. So Isaac Newton, to honor the scientist Isaac Newton, the unit of a force is given as a Newton. So it is denoted by the symbol capital N. So this is the SI unit. So what is the CGS unit? What is the meaning of a CGS? C stands for centimeter, or G stands for gram, S for second. So CGS unit of force is dyne. So you have came across this word dyne. So this is the CGS unit of force. So now we will see the relation between dyne and Newton. So 1 Newton meter or 1 Newton is equal to 10 power 5 dyne. So 1 Newton meter, this is the unit of moment of force. So 1 Newton meter is equal to 10 power 5 dyne. So if you want to convert this into centimeter, so 1 Newton meter is equal to 10 power 5 dyne. So meter, if you want to convert into centimeter, so you have to multiply by 100. 1 meter is equal to 100 centimeter. So finally it will come 10 power 7 dyne centimeter. So this is the relation between dyne and Newton. So next, second topic is moment of force. What is moment of force? It is also known as torque. So what is moment of a force? So moment of a force is nothing but it is the turning effect on the body about an axis due to the moment of a force applied on the body. It's nothing but it's the turning effect. If a body turns, if a vehicle turns, if any object turns, it's due to nothing but because of the moment of a force. So the moment of a force is a turning effect of the body. So what is the formula for the moment of a force? The moment of force equal to force into perpendicular distance. So perpendicular distance from the point O. From which point? Originating point O. Okay, so next, from point O, so it is equal to moment of a force is equal to F into perpendicular distance. So what is the unit of force? Newton. What is the unit of distance? Meter. So finally moment of a force is equal to 1 Newton meter, that we have seen already. So now what are the factors affecting the turning of a body? So what are the factors which will affect the turning? So first of all, the magnitude of force applied. Magnitude, amount of force applied. So magnitude of force applied. What is the magnitude of force applied? Means one boy is pulling with 10 Newton. This is the object. Another with 20 Newton. So which side the box will move? The box will move to this corresponding side with how much force? With 10 Newton extra force, because 10 Newton is applied by this boy A 20 Newton is applied by the boy B. So what is the more force applied by this? 10 Newton is extra applied here. So it depends upon magnitude of force. Second, perpendicular distance. So these are the two factors which will affect the turning of a body. Next, so now it is clockwise and anti-clockwise movements. So you are very much familiar with this clockwise and anti-clockwise. What is clockwise? So this side movement, the movement of your clock, this is known as clockwise movement. So it will start from this side, it will continue going this. So this rotation is known as clockwise movement. What is anti-clockwise movement? Anti-clockwise movement, so it's nothing but it will start in, it will be as in opposite direction as the clockwise. So its rotation will start from this side. So this is known as anti-clockwise movement. This is clockwise movement and this is anti-clockwise movement. Next, after this we have a topic of principle of moments. So what is principle of moments? Principle of moments. So principle of moments, what does the principle of moments says? That according to the principle of moments, sum of anti-clockwise moments equal to sum of clockwise moments. So this is what the principle of moments says, that the sum of anti-clockwise moment is equal to the sum of clockwise moment. So this is the principle of moments. Next we have topic center of gravity. Center of gravity. So what is the center of a gravity? So consider this is any stone. So which will be the center? This point will be the center of gravity. So the center of a body, is known as considered as center of gravity. It's nothing but the center of an object. So the first point to be noted here is the position of the center of gravity of a body depends upon its shape. So for example, circle, this will be the center of gravity. For rectangle, we have to move these three medians. So this point where all the three medians meet will be the center of gravity. For rectangle, square, we have to draw a diagonals where the both diagonals meets, that will be the center of gravity. For a square also in the same way we have to draw two diagonals where it will meet, that will be the center of gravity. And for a rod, consider this is a rod, so this will be the center of gravity. For any cylindrical object, so this will be the center of gravity. So first of all, it depends upon shape. Second, it is not necessary that the center of gravity always be within the material of the body. So if for example the center of gravity of a ring or a hollow sphere lies at its center where there is no material. Third point, by the concept of center of gravity, a body of weight W can be considered as a point particle of weight W at its center of gravity. So the weight W of an object lies at the center, this point. Next is uniform circular motion. So uniform circular motion. So what is circular motion? So if an object rotates about its axis, This is called circular motion. The motion of an object in around its axis or in a circular path is known as circular motion. Next is centripetal and centrifugal force. So what is centripetal force? So centripetal force means if the force which attracts the body towards the center, the force which attracts the body towards the center, that is called centripetal force. So it will be attracted towards the center. This is centripetal force. So next, what is centrifugal force? Oh yes, very good. You all can answer what is centrifugal force. So it will push the object away from center. Centripetal means towards the center, and this means away from the center. Away from the center. This is what centrifugal force. Next, so with this chapter gets over, this very small chapter which you have to learn, and two more topics are left behind in this chapter. Is that translational motion, and circular motion. So difference between translational motion and rotational motion. So what is translational motion? If an object, this should consider this is a path. So if a ball or if an object moves in a uniform, in a linear direction, in a linear straight path, so this is the keyword, a straight path, then it is said to be in linear motion, linear or translational motion. So if an object moves in a straight path, so it is known as linear or translational motion. So what about rotational motions? If an object is pivoted at a point at axis, consider this as O. So if an object moves by pivoted at a point, so this is known as said to be in rotational motion. If an object rotates about its axis, then it is said to be in rotational motion. So this is the major definitions of translational and rotational motions. If an object moves in a uniform linear straight path, it is said to be in linear or translational motion. So if an object rotates about its axis, then it is said to be in rotational motion. So with this we have completed this chapter in the proper way, and we must know about equilibrium. So there are two kinds of equilibrium. What are they? First one, static equilibrium. When a body remains in a state of rest under the influence of several forces, then it is said to be in static equilibrium. Suppose this is an object. One is pulling this way and the other is pushing this side. And even though the force is applied by the person A and the person B, then also the object is remaining at the same position, where it is at the same position. So then it is said to be in a static equilibrium. Even though more influence or several forces are applied on a particular object, then also the position of an object doesn't change, it remains at the same position, means this is said to be in a static equilibrium. Next is dynamic equilibrium. So second type of equilibrium is dynamic equilibrium. So when a body remains in the same state of motion under the influence of several forces. So we will learn also the difference between the static equilibrium and the dynamic equilibrium. So now we have seen one example that the box is at the rest. Even though the two forces are applied, the box is remaining at the same position. So then it is said to be in a static equilibrium. So what is about dynamic equilibrium? Now the body or the object is not in rest, it is in motion. So consider this object, any object, this is in motion. So even though many forces are applied, so there will be a friction on the ground, there will be air resistance, friction, which will be stopping this object will be stopped due to air resistance, friction. So this will be the factors which will try, or the force, several force which will try to stop this object. So even though this object doesn't stop, it remains in same speed that was at the rest, so it remains at the same position. So if it remains constant, in the simple word we say, if it remains constant, then it is said to be in dynamic equilibrium. So firstly we will see the difference between a static and dynamic equilibrium. So what is the first difference? The object is at rest in the same first static. Here the object is in motion. Even though many forces are applied, the object remains in same position. Remains its position here. Even though the force is applied, the object remains in constant speed. The object is in constant speed. So this is known as, so this is the difference between static and dynamic equilibrium. So with this we have completed this chapter. Let us have a quick recap what we have studied today, and we will be learning. So first, force. What is a force? A force is a push or pull of an object. So what is the SI unit of force? Newton. Why it is in capital? To honor the scientist Isaac Newton. So what is the serious unit of force? Dyne. So 1 dyne is equal to 10 power 5. 1 Newton is equal to 10 power 5 dyne. So if you want to convert the 1 Newton meter into centimeter in CGS units, then you have to multiply with 100, because 1 meter is equal to 100 centimeter. So 10 power 7 dyne centimeter. So next we have seen the moment of force. It is also known as torque. So what is the moment of a force? A moment of a force is the turning effect produced on an object. So the turning effect produced due to a force is known as moment of force. So what we have seen the formula of moment of a force. It depends upon magnitude of force and the distance. So force into distance from object point O. So we have seen moment of a force equal to force into displacement distance. So what is the unit of force? Newton we know. Displacement unit we know, meter. So moment of a force equal to 1 Newton meter. And then we have seen the factors which are responsible for the turning of a body. So the first is the magnitude of force applied, the amount of force applied on an object. And second, we have seen the perpendicular distance. Okay, these are the two factors. Third, we have seen the clockwise and anti-clockwise movement. So clockwise movement, it will be rotating from right to left. It will start in this way. So it will be denoted by negative. And anti-clockwise movement will start opposite from this side. From left it will be starting, and it will be considered positive. Next, so principle of moment. So we have learned that what the principle of moment says. That principle of moment says that the sum of anti-clockwise moment, so the total sum of anti-clockwise moment is equal to the sum of clockwise moment. So this we have seen in the principle of moments. Next we have the topic center of gravity. So what is center of gravity? The center of an object is considered as a center of gravity. So we have learned how to find the center of different objects. Next we have seen the circular motion. So if an object rotates, it is said to be in a circular motion. Then we have seen the centripetal force. What is the centripetal force? The force which attracts the object towards the center. So if the object moves towards the center, it is said to be have centripetal force. What is centrifugal force? Centrifugal force means the object will be tending to move away from the center. So if an object moves away from center, it is said to have which force? Centrifugal force. Then next we have seen the linear or translational motion. So when an object is moving in a uniform linear path, then it is said to be in uniform linear motion or translational motion. Then we have seen rotational motion. So when an object rotates about its axis and pivoted at a point, then it is said to be in rotational motion. Then next we have seen the kinds of equilibrium. So first we have seen a static equilibrium. So even though the several influence of forces are being applied on an object, if the object retains its same position, then we say that it is in static equilibrium. Then we have seen dynamic equilibrium. So when an object is in motions, even though the many forces are applied or trying to stop the object remains at a constant speed. So this is known as dynamic equilibrium. Next we have seen the difference between static and dynamic equilibrium. First, in the static equilibrium the object will be at rest, but in dynamic the object will be in motion. So the object will remain at the same position. Here the object will remain constant speed. So with this we end up today's class. So thank you for watching. Be updated with us. We will have the same videos from the same subject from the next chapter. So the chapter 2 we will learn chapter 2, which is work and energy, in the next class. Till then subscribe the channel. Till then, goodbye.